Question 4.
A box contains an unknown electrical component. This component is connected to two terminals P and Q on the outside of the box. A battery, an emitter, a switch, a lamp, and two crocodile clips are connected as shown in the circuit diagram of figure 4.1. The unknown component is either a broken wire or a connecting wire or a diode. A. Describe how to use apparatus to determine whether the component in the box is a broken wire,
Yeah.
a diode.
Connecting wire, then diode, right?
A diode. Yes, sir.
So have you tried this?
Yes, sir. I tried.
Yeah.
For the broken wire, I wrote the bulb will not lit up if it is a broken wire as the circuit is incomplete.
Mm-hmm. Then
For connecting wire, I wrote the bulb will lit up as the circuit is complete. For diode, I couldn't do it.
so diode, you don't have idea about diode, how the diode is working.
No, sir, I
Uh,
know what it is. Like it
sir,
lets current to pass through in only one direction, but I don't know how to write it
So
over here.
use your that idea. You know that diode, it will allow current in one direction. So the
Yes, sir.
lit light will lit if the diode is connected in forward biased only. This way I can write.
Oh,
Is it clear?
only when diode is connected with what is it, sir?
Light will lit light will lit only if the
Yes, sir.
diode is connected in forward biased. So you repeat, huh? The first one you
Yes, sir.
repeat
I have written.
so that others can also write it. The first one, what you said, again say.
The bulb will not lit up if it is a broken wire as the circuit is incomplete.
Very good. So Abir, what you wrote? Abir,
sir, I wrote the bulb will not lit up.
okay. It is also okay if we write it. Then next one, connecting wire. What you wrote?
The
The
bulb
bulb,
will lit up as the circuit is complete.
Okay, very good. Then Tamjid. Hello, Tamjid.
Yes, sir.
Have you written this two? A1, A2?
Yes, one.
Then
Yes, sir.
what you wrote about 3, A3?
Sir, I wrote the bulb the diode will not light up since
If diode will not,
if the circuit
the diode, no, you write the light will not lit if the diode is connected in reverse biased. Okay,
Oh, okay.
this way right.
Okay, sir.
The light will not lit if the diode is connected in reverse bias. And what Ifaz wrote?
sir,
Yeah, say
sir, for the diode, I wrote that the bulb will not be very bright. Can I write that?
what again?
The bulb will not be very bright.
I'm not getting the last word. Please say again.
The bulb will not be very bright.
Bulb will not be very bright for this,
Yes, sir, for the diode one.
for the diode one. Why? No, no. For the diode one, it will not be appropriate answer. Maybe you wrote the
Oh,
next one.
okay,
B.
sir. Hmm.
Part B, you wrote that one. That is the answer you told now. That is for part B, not for diode. Okay, for diode, you get either forward biased or reverse biased. In forward biased, the light will lit normally. It will be bright also, but reverse bias it will not lit. Is it clear? You
Yes, sir.
got it in electronics, right? Forward bias, reverse bias, introductory electronics, topic 24. Is it clear?
Yes, sir.
Now B. Abir, you continue B, part B.
The component in the box is a low resistance conductive wire. The second box looks identical but contains a high resistance resistor. Describe how to use the apparatus to determine which box contains the resistor.
Yeah. Describe how to use the apparatus to determine which box contains the resistor. So if there is resistor, what will happen?
The bulb will glow less or will be less brighter.
Yeah. Why? Why less brighter? Why less brighter? Can you say? Because if the resistance is high, you are getting less current, right? Isn't it? Hello.
Yes, sir.
Yes, sir.
In the second box, they are saying in the second box looks identical but contains a higher resistance resistor. That means you are getting less current, right? If you are having less current, then it will be less bright, isn't it? So light
Yes,
will
sir.
be dimmer as there is less current flow. You write also this explanation. That will make make more confident why it is less dimmer, right? So we are done with question 2, 3, 4, right? Isn't it?
Yes, sir.
Abir, Abir, we are done with question 2, 3, 4, right?
Yes, sir.
So question 2, you were disconnected at the beginning. We take the recording, huh? Abir,
Okay, sir.
then you'll get it. At the beginning, few minutes, you check the recording, then you'll get the ideas what to write. Now, this experiment is related to thermal physics. This experiment related to specific heat capacity. So read, huh? Tamjid read.
A student determines the approximate value for the specific heat capacity of water by an electrical method. The specific heat capacity of a substance is the amount of thermal energy needed to raise the temperature of 1 gram of the substance by 1 degree Celsius. He sets up the apparatus as shown in figure 1.1.
Okay. So you have the apparatus, right? So we have heater, we have glass beaker, then we have water, thermometer, power supply, ammeter. All these things are there. So continue. Yeah, Tamjid, continue.
He pours a mass m of water into a beaker where m is 100. He places a heater into the water in the beaker. He connects a voltmeter to measure the potential difference across the heater. Draw a voltmeter symbol on the circuit diagram on figure 1.1 to show the voltmeter measuring the potential difference across the heater.
So you know it, right? How to draw it?
Yes, sir, parallelly.
Yeah,
Yes, sir.
parallelly. Across the heater, right?
Yes, sir.
So across the heater means you should draw here, right? this here will be voltmeter and here will be
Yes, sir.
another part. Okay, so this way you connect parallelly. Then next, continue. Tamjid.
The table measures the initial temperature of the water and records it at time t equals to 0 in table 1.1.
A table is given. Then you read next part. Yeah.
Yeah. He closes the switch, starts the stopwatch, and records the temperature theta for the water every 60 seconds for 6 minutes. He records the current I in the heater and the potential difference V across the heater. His measurements are I equals to 4, V equals to 14.8.
Yes. So you got I. You have V, right? Next, continue.
Sir,
Yes.
so can you show where to draw the voltmeter again? I got disconnected.
Yeah. Voltmeter should be parallel with the heater, right? They
Yes,
are
sir.
saying to get the potential difference across the heater. So your voltmeter should be drawn parallel to the heater, right?
Yes.
So this side, left side of the heater, you give one wire, connecting wire, then
Hmm.
right side another connecting wire, then in the middle voltmeter symbol. Is it
Okay,
clear?
sir. Yes, sir.
Okay, very good. Now we have to close the class because 2 minutes left. Now you see we have a reading here, right? Thermometer. You have to measure the reading.
Yes, sir.
That means you have to find the reading, and this reading you have to write here. Okay. Then you are getting the readings, and all these readings you will draw the graph. Okay, smooth curve of best fit like before, and 200 seconds L theta you have to find, right? Then
Yes,
EVIT, this formula will apply, EMC del theta, this formula you know. So try as much as possible. Huh? Question number 1 at home, you'll try. This is another homework, okay? Hello,
Yes, sir.
are you clear about your
yes, sir.
homework? So try this question
Sir,
1 as much as possible. In our next class, we will continue, okay? In the
স্যার
meantime,
এইটার লিঙ্কটা দেওয়া যাবে?
yeah, we are showing it. You see, it's from your November 30, right? You got it? Google Classroom,
ওকে ওকে
November 30. So done, huh, everyone? Thank you so much. Allah Hafiz, huh?
I love it, sir.
Allah Hafiz.